Okay, I'm Captain Tadela of Ethiopian Airlines, and we are now set on a journey from Hong Kong to Madras, Chennai, and we'll be starting our pre-flight. We always start our pre-flights from the front of the aircraft, looking forward and taking the airplane from one side to the other, making sure that everything is good. Okay, so our pre-flight starts from the nose of the airplane. Make sure that nothing is destroyed on the radar. Then you go down to the pitot and the angle of attack indicators and the touch sensors. Then you go to the nose gear. We normally check that the nose gear tire condition is good. All the bolts are properly secured, and the nose gear area, that everything is tight, nothing broken or nothing leaking. And we check the steering pin and make sure that no gear pin is installed. Then we check the fuselage area, check the static ports over here, and check the doors are secure, but now we're going to load, so just make sure that nothing is damaged around here. And then come to the wing area, we check for leaks or any dents around here. Then we'll come to the engines, which are very vital. Make sure nothing is damaged on the engines or there is no leakage around the engines. So as we walk, we check the aircraft body for any dents or any damage. Come and check the blades around. Nothing is damaged, or the intake area. There is nothing damaged or dented. Then we do the same thing on this side. Check the engines and make sure that nothing is damaged around the turbines. Then we come and look around the wing area. Check for any damage thing or dents. Then you come at the tip and check the lights. Then start from the tail of the airplane and look forward all the way to the nose. Because of the distance, it gives you a good vantage to look at the airplane as a whole. So make sure there is no damage on the airplane. As you go back, you look at the other side of the wing, still making sure that there is nothing damaged, dented, or nothing leaking. Then we come to the landing gears to make sure that all bolts are secured, the tire is in good condition, and all the hydraulic lines and hoses are intact. And the brake wear indicators are checked. These are the brake wear indicators. So the same thing, we check the condition of the tire. We check the hydraulic lines, the gear condition, make sure that there is no pin installed. And we do it from the other side, the same checks. Then we go to the center gear. We do the same checks, no leakage, nothing damaged. sure the lights are not damaged, the antennas are not damaged. With the stabilizers, we check for damage or any leakage around the stabilizer. Then make sure the tail cone is secured and the area around the exhaust of number two engine. We do the same thing that we did in the front. We check for the aircraft's condition from this vantage. So we do the same thing from the left side too. On the left landing gear, we make the same checks that we have checked on the right one. Check the brake wheel, the general condition of the tires and the lines. Nothing is loose or damaged, or there is no hydraulic leak around here. So the condition of our tires is good. Nothing is leaking or damaged. So we do again the same check for the left wing as we did on the right one. Again, we look for any damage, dents, or any loose screws and the lighting system. Then again from this side we make the same observation. We start from the tail of the airplane, look forward all the way to the nose. Because of the distance, again, it will give us a good vantage to check the airplane in general. Again, we'll be checking the same things that we checked on the other engines. But there are no damage, dents, or evidence of any bird strike or something like that. Then we come on the left side of the airplane and also check the general condition of the fuselage and make sure the static ports are clear and all access ports are closed. So by coming back to where we have started, we finish our pre-flight, which is probably one of the most important parts of flying. Okay, the logbooks are clean and nothing significant on the stats page. Weather seems good all the way, and we don't have any significant SNOTAM affecting our flight. We're parked on Charlie 2, and we expect to taxi via Lima 1, then Kilo, all the way to runway 07 right, and runway heading 073 set. It's going to be flex 58, pax off, flaps 17 takeoff, set. It's going to be a noise abatement climb to 5,000 feet.
Wanna come in?
Stand by. Okay, takeoff runway 07 right, runway heading to Porpa, close at 220 knots and above 430 feet. Then right to Ramin, maintain 220 knots until the completion of the turn. Then cross it PM, Titan, Pecan and follow Victor 10. Transition altitude is 9,000 feet, MACA will take the highest, it is 4,300 feet. In case of engine out, acceleration is 830, we climb 4,300. Left turn to intercept Lima Kilo Charlie 104 radial until 9.5 miles, then right heading 185. We'll dump some fuel and request a rudder vector for ILS approach runway 07 right.
Papa Charlie Echo Tango Grand South. So in 614, contact tower south 118.4.
Good afternoon, ground. Victor Papa Charlie Echo Tango. Victor holding
Starting number 2.
Hotel Papa Charlie Echo
Over there.
South, Victor Hold Short Hotel.
Hold Short Hotel, Victor Echo Tango.
E5 70 Grand South, taxi Hotel Hold Short of Whiskey.
Say again?
E5 70 Apology City Hotel Hold Short of Victor.
Hotel for sure, Victor, E5 70.
For India 312, contact tower south 118.4.
Wanna come in?
Touchdown
Go ahead.
418.4, good day, please.
Sir, the push back is complete. Please set the target back.
Parking brakes set.
What is that?
Okay, you can clear the ground, go to hand signals, have a good day.
What is that? Okay, number one, hotel 01 holding for expanding and bridge.
Left. Chickens. Right. Chickens. Elevator down.
Tower Chinese 504, taxiway hotel.
Chinese 504, Tower South.
Good day, Dragon 063.
Dragon 063, Tower South. Japan Air 28, contact departure 123.8.
1238, Japan Air 28, good day.
Harry 61, contact tower 118.2.
41643.
Dragon 840, wind 310 degrees, X north, runway 07 right, clear for takeoff.
Take off runway 07 right, Dragon 840.
Ethiopia 3719, line up and wait, runway 07 right.
Line up, wait, runway 07 right, Ethiopian, so runway.
Chennai to departure, get back. Before takeoff checked. 8 is checked. 9 steam. Landing lights are on. Spoiler radars are on. Transponder steering.
Dragon 840, contact departure 123 days, no 8.
123, go to Dragon 840.
Okay.
Ethiopia 3719, wind 310 degrees, 8 knots, runway 07 right, clear for takeoff.
Everyone take off runway 07 right, Ethiopian,
Chinese end 504, line up and wait, runway 07 right.
Line up, Rio 7 right, Chennai, 07 right, Chennai 504.
On the flight. Check thrust. Thrust it. 80 knots. That's V1. Rotate.
Welcome to Tower, sorry, Dick Tower, 714.
Right gear.
DXL 714 Tower South 5, Juliet 6 holding point, stop runway 07 right after crossing, left turn on, kilo expedite.
Roger, cut runway 07 right after crossing, left one.
Off.
Dick Tower, 714.
Up.
Ethiopia 3719, Ethiopia 3719, Roger, climb to 7000 feet.
Flash out. Land 5,000 checks.
Hello, 770, standing 016, starting 59.
Ethiopia 3719, high speed approved.
After the approach, over.
Ethiopian 379, I'll call you back if available.
Papa level 380, Dragon 206. Dragon 206 is flight level 400 available.
Dragon 206, standby.
Hong Kong, good afternoon. EVA 6076, maintaining 1,300 meters.
EVA 6076, Hong Kong radar Delta 5. From Tamar, direct Rasi, report and for estimate.
Confirm from present, direct Rasi, EVA 60.
Short shortly we'll be flying over Vietnam. Then comes Laos, over the border. We'll be crossing the Mekong River, and over the border with Thailand. Then of course we'll be flying over Bangkok, then turn west, fly over Bay of Bengal and the Andaman Sea. And Chennai is just over the coast of the Bay of Bengal.
Hello, Control, Vietnam 118, good afternoon.
Good afternoon, Vietnam 118, great contact, maintain level 350, the way to Vanu.
Maintain 350, direct.
Okay.
I'm Captain Tadala of Ethiopian Airlines. I'm the chief pilot on the MD11. Ethiopian Airlines owns two MD11s, and they operate to Hong Kong, Liège, that is in Belgium, and we fly from Liège to Accra, Lagos, Brazzaville, Port Noir, and again from Addis to Joburg. And sometimes we also fly to Dubai and Mumbai. The MD11 is initially developed and built by McDonnell Douglas. It is a wide body, medium to long range airplane with 3 engines, 2 on the wing and 1 on the tail. It is basically a DC-10 that is improved both for its length and the length of its wings, as well as its capacity. And some of the technologies used on the MD11s are one of the modern technologies, and it uses some composite materials too on the construction. It can carry about 96 tons of cargo and about 116 tons of fuel, and flies about 9 hours or more, if it is fully fueled, that is. The aircraft has a takeoff weight of 286 tons. That's mostly at sea level. In Addis, we are restricted due to the altitude to about 245 tons. Since Addis is at a very high altitude, and it has a landing weight of 223 tons. On the rest, First Officer David will give you more explanation about the setup of the airplanes. And just to mention the bigger difference with the DC-10 and the MD-11, the other big difference is instrument layout. This is a cockpit glass, rather a glass cockpits, and the DC-10 is a conventional cockpit with analog indications. So David will continue with the briefing on the airplane.
Okay, good afternoon. My name is First Officer David. I've been around as Ethiopian Airlines for now 7 years now. I've been flying the MD-11 for now 18 months. And today I think we are flying from Hong Kong to Addis via Chennai for a technical stop at Chennai. Then after 1 hour stay at Chennai, we'll continue flight to Addis. Today we have cargo of something like 80 tons from Hong Kong, and the weather is good en route, and expect good conditions at Chennai. For now, I'll just brief you around about the layout of the MD11Cockpit. Basically, we have everything that we need on the PFD now. For instance, we are maintaining Mach decimal 8 almost. We are maintaining altitude of 2,000 feet. We're on heading of 352 now. Currently, the flight management system is taking over, and it's coupled with the autopilot. So we are currently the autopilot is currently flying what we have put in the FMC. Currently, we are flying over the airspace of Thailand, and we can actually see this routing on the maps. This is a navigation display, and the navigation display we can in this airplane you can also see the weather en route. We have the weather radar controls over there, and currently we have some weather. It's not that bad or affecting our routing. So on the weather radar you can actually see the different shades of color, like the yellow, the green, and if it's severe weather you can actually see the rain, just like this one, for instance. And the navigation display, you can also you have some other information like wind data, like wind coming from the south. On the PFD we normally use it as a primary flight display. We have the flight director over here, so the airplane is actually following the vertical and lateral guidance from the flight management system. So we have both controls, both displays on both sides of the cockpit. Since this display is quite critical, you can actually interchange it to the other side, to the fifth display unit. In case there's any failure, you can transfer it from to this side of the display. And with the cockpit, also have the primary engine displays like the N1s, the EGTs, and these are actually parameters from the engine. We normally monitor them, and if there's any malfunction, you can monitor them through these displays. You have also secondary engine displays, and also here we can actually see the weight of the airplane that we are actually carrying, the fuel we have on board, the cabin altitude, and the start trip setting, and also the CG. The CG is quite important in this airplane. Also, we can also monitor the hydraulic systems and the control for the hydraulic system over here. So currently we have 3 hydraulic systems operational. For this flight, you can actually see the electrical system, the output from the 3 engine-driven generators. We can also see or control the air system. For the 3 bleed system, 3 pack systems, you can actually see the cabin altitude and the landing altitude, also the position of the outflow valve to control the pressurization of the airplane. We can also see the fuel system on this display. The fuel system, you can actually see the amount of fuel that we have on board on each tank. Currently for CG or center of gravity control, the airplane is transferred automatically some amount of fuel to the tail tanks. We can actually carry fuel in the tail tank, in the tail of the airplane. Also the configuration page, you can see the tire pressure and temperature that we have currently. This display is quite important to monitor the system of the airplane. We have the mode control panel. The mode control panel is used to couple the auto-flight system with the flight management system. Currently, where the autopilot system is coupled with the flight management system. So what we have put on the FMC is being flown by the autopilot now. The autopilot 2 is now riding the airplane, and here we can see different controls for the altitude, the heading of the airplane, or the speed of the airplane. And these are the buttons that are used to engage what we have calculated on the FMC to the autopilot. We have this control panel here, which is used to show this different displays like the traffic or the data, or to see what we are planning. For instance, on the approach to Chennai, we can actually see how we are going to approach to our landing runway. So currently we have planned it to join downwind, but anyways we will be expecting radar vectors, but the plan looks like we'll be joining downwind, just maintain 4,000 here and come down to intercept the localizer and ILS for runway 07, so we can actually visualize the whole pattern for the approach to the runway. Over here we have the system control panels over here. We have the IRUs as we have in some other airplanes. We have the inertial reference unit over here. We have the hydraulic system controls, and we have the electrical system controls. We have here the air system control and the fuel system control. These systems are actually controlling the respective hydraulic, air, fuel, and electrical systems automatically. But if there's any problem, we can actually take over manually and control those systems as we like. Here we have the throttles to control the power setting of the airplane. We have the flap levers, which is quite unique for this airplane. We can actually optimize the flap setting from 10 to 25 for takeoff. And as long, the logi pad or the computers can actually calculate the flap settings that are required for specific settings like temperature, wind, and the weight of the airplane. And we can actually get optimized flap setting and actually set the flap setting from 10 to 25 as we like it. We have the spoilers over here and the landing levers down here. And these are the standby attitude indicator. The standby attitude indicator is actually the same as this one, but this one is more reliable, and this one is actually showing you the attitude, and you have the standby airspeed indicator. In case there's any, there's a complete failure of the display unit, you can actually use these standby units to actually navigate and fly the airplane. This airplane, we have 3 CDUs here, one for the captain and first officer, and we have a third one for this one. We have 2 flight management systems, flight management computers in this airplane. And these airplanes are actually normally work in dual mode, which means that the computer actually do the computing independently, but in normal situations we have the dual mode of the flight management system working. So you can see the output of that flight management system is these 3 CDUs. We use a flight management system for to monitor the flight progress. For instance, you can see that we'll be landing at Chennai, India, at about 1300 Zulu. We can actually use the flight management system to calculate performance of the airplane. Like you can actually have the landing speeds over here. You can actually fly the flight plan that we put on the ground. So this computer is quite useful as far as the navigation is concerned. So we can do any modifications that we like on the flight management system. Like now, currently we're now flying direct to a point by the name of Lalit. It's inside the airspace of Burma. It's in Yangon. But you can do all the modifications that you like. You can also put some database. You can also put some navigational waypoints in the fixed page. You can also monitor how much fuel we're left with, how much, what our landing weight is, and things like that. So the flight management computer is quite useful for our daily operation.
Cabin clear, pilot support 107.
100 clear to the approach, calling localizing 07.
This is Sunshine Nagara, descend to 588.
Position 8007.
Stop at 3006.
1000.
For landing charges. Here.
Now for breeze.
Spoilers arm, water brake, VKD, straight. Flaps.
50 degrees.
Land. Clears.
Confirm it.
Well, sorry.
Tower 278. Good evening, 14 miles. 278, good evening, continue course and interest and maintain 020 degree and 05 knots.
500.
278.
Approaching minimum. Minimum. $150, 30.